Okay, today we're going to be doing looking at different types of data. So we can think of there being two types of data. The first type is qualitative. Sometimes known as categorical. And this is non-numerical. An example of this would be blood type, or colours, or something that you wouldn't be able to define with numbers. The second type is quantitative. And we can further divide quantitative data into two other groups. So the first group would be discrete data, and the second would be continuous. So discrete data is data which takes on, they can only take on certain values, and continuous data can take any possible value. So if you think about like a number line, and this is the range within which your data lives. The discrete data would be taking on particular values throughout that range, and it doesn't need to be spread out evenly. You can have them really close together, they can be more spread out, but the discrete value data has to take a particular value within that range. Examples would be, say you were looking at the number of letters. If you had like a paragraph and you looked at all the words within that paragraph, and you counted every letter that's in the words. So they could words could have 1 letter, 2 letters, 3 letters, 4 letters, 5 letters, etc. And you made a tally chart, and you recorded how many words there are that are 1 letter long and how many with 2 letter longs. That would be discrete data. No words are going to have 3 1/3 letters. You can't get that. Just doesn't make sense. That doesn't mean to say that discrete data can't take non-integer values. So they can have so discrete data can be integer values or non-integer values. For example, shoe size. An example of continuous data would be the times taken to run a race. So obviously, depending on how accurate your equipment is, you can do it to the nearest second, 1/10 of a second, 100th of a second, etc. And so on, and it can take any set of values within that range of the of how long it would take to run that race. And so what we need to then do is have different ways of, but once you've got your raw data, you need to be able to present that data in a way that's more usable than just a whole big list of numbers, which is quite hard for us to look at and to really interpret. And so the way we deal with different types of data changes. We won't deal with our continuous data in the same way as our discrete data. So we're going to now look at a way to present discrete data to make it more user-friendly. And that is by using something called a stem and leaf diagram. And it is useful for representing small amounts of discrete data. So the last digit, so what we have like, so this would be, we'd have a list of digits, this would be our stem, and then we have leaves coming off this stem. The last digit of each data value appears as a leaf on this part here, and the other digits appear on the stem. The digits are ordered vertically on the stem, and the digits on the leaves are ordered horizontally. So they'd go from smallest to biggest. Now, the easiest way to really think about this is when we're actually looking at an example. So it'll make sense when we're actually looking at an example. Each row, so each of these rows is called a class of values. And the width between each class is the same. The rows have equal widths. We need to have a key to explain the values represented. Stem and leaf diagrams are particularly useful because you still can see the raw data, but it just orders the data in a form which is more user-friendly. And you can also you can have a stem and leaf diagram where you've got one set of data coming this way, and then you can have another set coming out this side as well. So they're back to back, and that allows you to be able to compare different sets of data more easily. So let's consider the raw percentage points of 15 physics students. And this is what they get. So we've got 58, 55, 58, 61, 72, 79, 97, 67, 61, 77, 92, 64, 69, 62, and 53. So we're going to represent this in a stem and leaf diagram. So what we're going to do is we see the lowest one is 53 and the highest is 97. And so we're going to make the widths of each class 10. We're going to jump up in tens. So we're going to kind of group them in tens, and we'll start, because the lowest is 53, we're going to start with in the 50s. And so down our stem we'll have the tens. So 56, 5, 6, 7, 8, 9 for the tens value. So let's do that. So we've got 5, 6, 7, 8, 9. So there's our stem, and our leaves are going to come out here. So let's look for everything where's that's in the 50s. So we've got 58, then we've got 55, we've got another 58, and here we've got a 61. This one's 72, so we'll put 2 here, and then we've got a 79. Then we've got 97. Then we're back to 67, so 67, 61, 77, 92, 64, 69, 62, and then the final one is 53. Now we're going to rewrite this. We want to keep this in. We want the leaves to be in ascending order, so smallest to biggest. So I'm going to rewrite it over here because I've got more space. So we'll do our stem again. Now it's important when you're doing these when you do your leaves and you do your stems, to keep the digits equal distances apart, so it's all the digits are all nicely aligned, because it just helps you to interpret the data. And you're going to be what you're going to end up with something that looks very similar to a bar chart. So the first digit here is 3, the smallest digit is 3, then we've got a 5, and then we have 2 8s. Then in the 6s we've got 2 1s, and then we've got a 2, and the next one's a 4, a 7, and a 9. Then in the 7s we've got a 2, 7, 9. There's nothing in the 8s, and then we've got the 92 and the 97. And then we have to write our key. So we'll choose 5 and 3. So the first entry represents a score of 53%. So that makes it clear what we're doing. Now, you can order them the opposite way around. Sometimes you may be asked to represent the data so it goes from biggest to smallest as well. So that's something just to be aware of. If you have an awful lot of data, you may want to include, like if you had, say, 30 leaves, you may want to change the widths of the rows. So it was 0 to 4, 5 to 9, 10 to 14, or something like, etc., etc. But once you're getting big data sets, stem and leaf diagrams start to be not as useful as they are with these small amounts of data. So let's look at an example where we have a back-to-back stem and leaf diagram. So the number of days on which it rains in a certain town each month of 2016 and 2017 are given. So we've got the year 2016, and we've got January, February rained 20 days, in March it rained 13 days. April, it rained 12. May, 10. June, 8. July, 0 days. August, 1 day. September, 5. October, 11. November, 16. And December, 9. Then in the following year, we have January, 9 days. February, 13. March, 11. April, 8. May, 6. June, 3. July, 1. August, 2. September, 2. October, 4. November, 8. And December, 7. So to compare the back-to-back, on one side the leaves are going to be 2016, and on the right hand side it'll be 2017. And so let's draw our stem. Because a lot of the months had single digit days of rain, we'll have a 0 here because it's 0 tens, then 1 10, 2 10, so it's for the 20s. And that's going to be, I don't think anyone had, well, we could do 20 days of rain here, so, and this will be 2016, and this will be 2017. So let's go through 2016. So we have July had 0, August had 1, and then we had September with 5, and June had 8, and then December had 9. And then for the tens, we have, is any 10 days of 10 rain? Oh yes, May had 10, October had 11, and April had 12, March had 13, and November had 16, and January had 17, and February had 20. So let's do 2017. So again, July had 1 day of rain, August had 2, September had 2, June had 3, October had 4, 6 days, where was there's May had 6, December had 7, and November had 8, and so did April, and January had 9. And then we have March with 11 and February with 13. And that's all the months for 2017. So now we need to make our key clear. So we've got 5, 0, 6. So it represents 5 days in a month of 2016 and 6 days in a month of 2017. Now, what this stem and leaf diagram no longer tells us is which months had which rainfall. It also doesn't tell us the quantity of rainfall. So the information, it said, we can find out from this that it rained on more days in 2016. So it rained 122 days in 2016 and it rained 74 days in 2017, but it doesn't tell us if there was more rainfall in 2016 because those days might have been very light rain and the 74 days in 2017 might have been torrential rain. It doesn't give us that information about the actual annual rainfall. It just tells us how many days experienced rain in both of these years. So I hope that makes sense.